Hi, you can use this video today to help you solve two-step equations. There will be 5 examples that I will explain and help you work through. Some of the key phrases that you've heard me say over and over again that you might find helpful as you work through these are: remember that the goal is to isolate the variable. You do this by working backwards or doing the opposite, using the inverse operation. And then what's really going to be key here with two-step equations is that you always get rid of the number least attached to the variable first. And also, don't ever forget the golden rule of equations. Whatever you do to one side, you must do to the other. Let's get started with example number 1. Remember that the goal is to isolate or to figure out what our variable is, which is n. So I'm going to circle it. Well, I need this by itself. I need to isolate it, which means I need to get rid of this number 2 here and this 3 or this negative 3. And I always do this by working backwards or getting rid of the number least attached to the variable. Well, this 3, the subtracting 3 is least attached to the variable. So to undo subtracting 3, I add 3 because a negative 3 plus 3 is 0. It cancels out. That's what I want to happen. I want it to go away. Well, the rule of equations is whatever I do to one side, I have to do to the other. It is helpful to split your equation down the equal sign with a line, because whatever you show on one side of the line, you should show on the other. Well, then you just do the math. Negative 3 plus 3, that cancels. That's gone. It equals 0. So what I have left is n divided by 2. On the other side, I just do my simple addition. 5 plus 3 is equal to 8. Remember that this line represents an equal sign because I have two different sides of, like a scale or a balance. Well, now I have a variable. I'm dividing it by 2 and it equals 8. Well, I still want to work backwards, or I want to do the opposite of what's happening. The opposite of dividing by 2 is multiplying by 2. So you can multiply both sides by 2. And as long as I do the same thing on both sides, my equation stays equal. It stays the same. Well, dividing by 2 and multiplying by 2, they are opposites. They're inverse operations. They cancel each other out. So now what I have left is my variable n. And then I do the math over here. 8 times 2 is equal to 16. I can always go in and plug this in and check. That means that This means that if n is equal to 16, this equation will in fact work out to be true. So I'm going to plug in 16 for n, so that would be 16 over 2 minus 3 equals 5. Using order of operations, I would need to divide first, so 16 divided by 2 is 8. That would be 8 minus 3 equals 5. Then you want to check, is this in fact balanced? Is this in fact true? Is it a true statement? Well, 8 minus 3 is equivalent to 5, and 5 is equal to 5. So I know with 100% certainty that this solution of n is equal to 16 makes this statement true and is the only solution for the variable n that will make it true. Okay, here's example number 2. I want to work backwards to get x by itself. I need to get rid of numbers least attached to the variable. Well, this time it's the number 5. So to get rid of a positive 5, I would subtract 5. And the rule of equations, whatever you do to one side, you have to do to the other. There's my line to keep it balanced, which is an indication of my equal sign. On this side, 11 minus 5 is 6. And on this side, 5 minus 5 is equal to 0. So that leaves me with a plus 3x or a positive 3x, but we don't write positive signs in front of numbers, so I can just drop 3x. Now, I have worked this to being a one-step equation, which means that 3 times a number equals 6. To undo multiplying by 3, I do the opposite, which is dividing. And again, the rule, if you do something to one side, you have to do it to the other. So that cancels, so I'm left with x. Because 3 divided by 3 is 1, 1x is the same thing as x. And then 6 divided by 3 is 2. Again, I want to be absolutely certain that this answer is correct, so I plug it in. So I see if 11 equals 5 plus 3 times 2, because I'm plugging 2 in for x. You would multiply before you add. 3 times 2 is 6, plus 5 and I see if those are equal. 5 plus 6 is 11. I know that my equation is balanced, so I know that this solution, 2 is equal to x, or x is equal to 2, is correct. Example number 3. Again, you could look at this and you could switch the order that you write these. That's the commutative property. You could rewrite this part of the equation to look like x divided by 11 plus 6. That is fair game. However, I would encourage you just to try to force yourself to work through it this way, because you're going to continue to see equations written like this as you go through school, and it'll just be easier for you if you can just solve it the way that it's written. So again, I want to isolate this variable, and to do that you work backwards, getting rid of numbers least attached to the variable. Well, which number is least attached to the variable? Well, it's 6. So to get rid of 6, it's a positive 6, so you would subtract 6. 6 minus 6 is 0. That's what we want to happen. Whatever you do to one side, you do to the other. So I'm subtracting 6 on both sides. That's fair game. That's the subtraction property of equality. As long as you do it to both sides, your equation stays equivalent. So over here, 4 minus 6, remember you could change that to adding the opposite, those integer rules. You're adding opposites, so you subtract. 6 minus 4 is 2, and 6 is your bigger number, and it's negative, so this is in fact negative 2. Again, we said 6 minus 6 is 0, so that's gone. It cancels each other out. And then you have x over 11 on the right side. So now you have a one-step equation, which if you read this, it would say negative 2 is equal to x divided by 11. So you're looking for the number that when you divide it by 11, you get negative 2. Well, to do that, work backwards. So get rid of or undo your dividing by 11, which means multiply by 11. And whatever you do to one side, do it to the other. So on this side, dividing by 11, multiplying by 11 cancels out. So you're just left with your variable x. That's what we want. Over here, you've got 11 times negative 2, which is negative 22. Plug it in and check. Make sure that you get your answers right. So that would mean that 4 is equal to 6 plus negative 22 divided by 11. If you're looking at this like an order of operations problem, you would divide first. Negative 22 divided by 11 is negative 2. 6 plus negative 2, you're adding opposites, so you subtract, they cancel each other out. That would be a positive 4, and that is in fact equivalent, so you know that this solution of negative 22 is equal to x is true. This is often the most missed question on a quiz or a test, and the reason it's missed is because we have said that you work backwards using order of operations, so everyone thinks that you need to subtract 5 first. However, if you think about this like the shoe and sock example, you are starting with a number, adding 5, and then dividing it all by 3. It's kind of like taking your socks off before you take your shoes off. You can't do it. The very last thing you do in this problem is dividing everything by 3. That's the first thing you need to undo. So the opposite of dividing by 3 is multiplying by 3. So if you multiply both sides by 3, check what happens. Dividing by 3 and multiplying by 3 cancel. So that leaves you with n plus 5, because we've undone the dividing by 3. And then negative 7 times 3 is negative 21. Now you can get rid of your adding 5. To get rid of adding 5, you do the opposite, which is subtracting 5. Golden rule of equations, whatever you do to one side, you have to do to the other. So plus 5 minus 5, that cancels, so you're left with n. This one, remember, subtracting is the same thing as adding the opposite. So if you change this to adding the opposite, what you have is negative 21 plus negative 5. So you start with 21 negatives, you have 5 more negatives, you're adding the same sign, so you add those numbers, and you keep the sign. So n is equal to negative 26. You can plug this in and make sure that it works. If you plug in negative 26 for n, that would mean that when you take negative 26 plus 5 and divide it by 3, it would equal negative 7. Well, before you can divide, you have to figure out what this equals. Negative 26 plus 5, you're adding opposites, so you subtract. 26 minus 5 is 21. You've got more negatives, so that's negative 21. Then you would divide that by 3. Well, 21 divided by 3 is 7. You've got one negative here, so that's negative 7. And over here you have negative 7. That's equivalent. So you know that your solution of negative 26 is correct. Your last and final example. Remember to work backwards, getting rid of numbers least attached to the variable first. The number least attached to the variable is -8. So to get rid of or undo subtracting 8 or a -8, you add 8 on both sides. Can split that equation if it's helpful. -8 plus 8, gone. It equals 0. So you're left with -4b over here, because you just drop everything that you haven't canceled. And then -24 plus 8, look at that, you've got opposite signs. When you add opposite signs, you subtract. 24 minus 8 is 16. Your bigger number is -24, so that's negative. Remember, that indicates an equal sign. So what you have is -4b is equal to -16. This represents multiplication right here. So to undo multiplication, you divide. So divide both sides by -4. That cancels or equals 1 or 1b, which you don't need to write 1 in front of it. You just put b. And then 16 divided by 4 is 4. And when you divide two negatives, your answer is positive. So your answer is b is equal to 4. Remember, you can always plug this in to ensure accuracy. That would mean that -4 times 4 minus 8 does in fact equal -24. Let's just go ahead and prove that. So we get 100%. We have multiplication and subtraction. You always multiply first. So that would be -16 minus 8. And we don't really like to subtract, so we change that to adding the opposite, so adding a negative. So -16 plus -8, you're adding the same sign, so you add those numbers up. 16 plus 8 is 24. You keep the sign, which is negative, and that is in fact equivalent to -24 on the other side, so I know my solution is correct.